Hi again. Now that we know about GANs and how to train them and how they relate to other generative models, let's meet some interesting variants of GANs in this lecture. So far, we have only seen GANs that take a random noise sample and generate a random cat face, for example. But how can we control this generation process? For example, if we train our GAN on a data set of mammals, can we ask it to generate a specific mammal that we can pre-specify, as shown in the figure here? This is actually possible thanks to the conditional GAN model. Conditional GAN introduces a simple yet powerful way of conditioning the generation process onto the labels. In contrast to vanilla GAN, where we only feed the images from the real data set and the generator in the discriminator, in conditional GAN, we concat the image and Z with the label of the real image and then feed it to the critic. And that is it. This simple change allows us to learn conditional distribution of x given y. This trick is so impressive, it is also used in recent methods like PicGAN. So what else can conditioning do? We saw how to condition on labels, but what about conditioning on a random variable? This is made possible by InfoGAN. It is similar to conditional GAN, but we only concat the random variable to Z. And we also train a separate network that shares some parameter with the critic to predict this random variable. The principle behind this GAN is that of mutual information maximization. That is, the model is trained such that the mutual information between x and the random variable y is maximized. Among other things, InfoGAN is useful for learning meaningful and disentangled representations. We briefly mentioned in the previous lecture that GANs are connected to VAs. In fact, using conditioning in a specific way, one can rewrite GANs as an upside-down VAE, that is, autoencoding of noise. This also allows for posterior inference in GANs, just like VAEs. Finally, conditioning in GAN comes in many flavors. Even the exciting GAN-based style transfer methods are basically conditional generative models. And the list goes on and on. Okay, that brings us to the end of this lecture. See you in the next one.